Delighted to be here and delighted to speak to a skeptical crowd. The subject that I'm talking about is one that has, over the eons, been in the forefront in people's minds and has been worthy of a great deal of skepticism because it really wasn't science. What I'm going to try to walk through today is how it is becoming science and some of the things that we're learning, which are, to me, really remarkable. My background is I've been a science writer at the Post for the last 12 years or so, but I've also been a foreign correspondent a lot and a lot of other things in journalism. And of all the things that I've done, including war reporting and political reporting, whatever else, this has been to me the most interesting. To really dig into the issue of life beyond Earth and to spend so much time with like really brilliant and really interesting scientists, which I've been able to do for the last couple of years. So with that, here it is: life as we don't know it. And when, as we said in the introduction, I mean, this is indeed a subject that has been out there forever. People have wondered about it, and when you kind of put it into the broadest context, virtually every human society has projected life into the out into the cosmos. We have angels, we have heaven and hell, we have djinns in the Islamic tradition. We have Mormons believe that there are extraterrestrial intelligence on other planets. The Chinese have the Jade Mountain, that is inhabited. So it seems to be something kind of deeply hardwired into human beings and societies to think that there is life out there. And the issue is that something that we're intuiting, or is it just something that we really wish was true? And that's kind of what we're going to be talking about some. And again, as a group of skeptics, this is perhaps you're familiar with Giordano Bruno, who was a skeptic in his own way back in the 16th century. He started life as or his professional life as I'm not sure professional is the right word, but as a Dominican priest, gradually became disaffected, became a writer, and then became kind of a free thinker. And one of the things that he thought a lot about was life on other planets and other universes and things like that. Things that are very much the norm now, but weren't back then. This was the time of the Spanish Inquisition. This is the Campo de Fiori, which is about a half a mile from the Vatican, and this is where he was burned at the stake. And one of his primary heresies was that he said that there was life elsewhere in the universe, which was not the Church's position at the time. So what you think about life beyond Earth at different times has had pretty serious consequences. As society becomes more secular over the years, when you think about it again, what are UFOs? What's all the thought about aliens coming to Earth? It's kind of the same aspiration, the hope that there are somehow beings out there, but there is no science associated with it. I mean, there are some claims that have been made in terms of research that that some of the explanations that people give, descriptions are similar, but in terms of rigorous science, there's nothing. However, this is kind of what my subject has been. It's new to humankind, the real science of extraterrestrial life, and it is something that, as I'll describe, has really blossomed in the last 10, 15 years. No pun intended with the blossoming, because this obviously is not a real picture, and you're skeptical folks. I want to quickly go to a real picture. I don't know how the quality of that, but that's Mount Sharp. That's Mars. That's where we are now. I mean, that's where curiosity is, and I can't exactly tell with where I am, but you can see there are all kinds of striations in here, which just has the geologists going nuts, because striations are what they live on. That's how that's sedimentary deposits, perhaps, and there is such excitement, and we'll talk about some of that later too. But this is the real deal. This was taken by curiosity, and unless one believes that we never did go to the moon and we never did really go to Mars, this is real. All right, the new era of astrobiology, as it's called, really kind of began with a thud, as it were, with this meteorite, ALH 84001. It had landed in Antarctica, and some researchers down at the Johnson Space Center worked on it for quite a few years and wrote a paper that was in the lead paper in Science. And there was a big NASA press conference when it came out, and they said there are 5 indicators here that appear to say that there was life once in this meteorite or associated with the meteorite. And again, it was in terms of what an organism does to rock. There also, most controversially, they said that there was potentially a microfossil in there of an amoeba, a microbe of some sort. This became hugely controversial. It was very quickly attacked by a lot of different scientists for a lot of different reasons. The person who was most in charge of it, I've spoken to in recent years, he feels even more than before that it is accurate, that Mars and that other Mars meteorites show similar kinds of evidence. But as of now, the consensus view is that this did not meet the grade, and so skepticism won out in this one, and this is generally not considered to be exactly, precisely what they said it was. However, and here, this is the kind of microfossils that are sometimes seen in other meteorites as well, Martian meteorites, and I believe this might have been the one from ALH 8401. The question is this contamination? Is this something real? Is it just a non-biological, something that was never biological? And there's going to be a lot of discussion and research about this in the future, because we have increasingly good ways of determining that meteorite samples are from Mars, and so we're finding more and more of them, and now we have better and better ways of looking at them. All right, so astrobiology. A science without a confirmed sample, but look at this. I mean, this is astrobiology, and this is, you could even add to it. It is probably the most broadly interdisciplinary field, or one of the most in science, and it's enabled like that. And you go to a conference, an astrobiology conference, and now you can, there'll be 10,000 people at one of these conferences, scientists, and they will be from microbiology, from chemistry, from physics, from cosmology, from geology, and they're all studying these different kinds of issues, some of which we'll talk about, and it is an exciting field. NASA has an arm called an Astrobiology Institute that gets a small sum of money that it can give out, but really the astrobiology effort goes a lot more than that. I mean, Curiosity is in effect an astrobiology mission. And they even say that, NASA does. But they're also, this has become a big enough subject that, and a pressing enough subject that institutions and universities all around the world are working on it. There's an astrobiology institute in Spain. There's a lot of work going on in the UK and Russia. And so it is in many ways one of the top fields of the future. And now this is what I'm going to kind of walk through. And Again, I am not a scientist. I don't have a great science background. In a way, I kind of feel like my biggest qualification for doing this subject and for writing this book was that I was a foreign correspondent in Asia for a long time, and I learned how to translate what people were saying. And you know, I would go to talk to Steve Benner, who was a renowned chemist who's working on synthetic biology, and you know, he would put all the stuff on a blackboard, and I wouldn't understand it. And you know, like 3 or 4 days later, I would understand it. So that's what I've sought to do in my writing for the Post and for this book and for National Geographic. In any case, this is what I'm going to try to lay out. That life is far more tenacious than was previously imagined. This is the whole world of extremophiles, and we'll go into that in some great detail. That there are many billions of exoplanets that it's no longer likely to exist, that we now know do exist. And it's like many billions. You know, we have our, used to be 9, I guess it's now 8 planets in our solar system. Now there are billions of other solar systems out there with planets. And a habitable zone is an area around that the star that would be the center of a solar system, and it's basically defined by an area where water can sometimes be liquid. It's not too hot that it all burns off, not too cold that it all freezes, although freezing might not be as bad as people think. But we now know that there are probably a lot of habitable zone planets. This is the part that really kind of blew me away as someone who was something of a novice in this, that all the molecules and compounds, the hydrocarbons, sugars, everything else that is needed to create life, it's all out there. We all know that. I mean, amino acids, they're in space, they're in meteorites, they're in gases. So it's all out there. If life started once, why not again? Well, this is where we get into kind of the basic philosophical issue or probabilistic issue, which is when we walk through all these other things, it seems highly improbable that it didn't start elsewhere, and virtually impossible. And then here's just kind of the closest we're going to come to have a slam dunk kind of proving it in the near future or the medium future in Mars or perhaps Europa or Enceladus or one of the other moons in our solar system. If there is a finding that there is or was biology on one of these planets or moons, and it's a different structure than what all life is based on here, in being DNA, then you have 2 geneses, if you would, of life in one solar system, and the probability of life being a commonplace goes up like that. So that's why curiosity and Mars are so important, because that would speak to that last subject. Excuse me. All right, so extremophiles, life in extreme places. Who knew? Well, black smokers, they're heat vents at the bottom of the ocean, and they were first really discovered, I think it was back in the 60s, 70s, but fairly, and it's after that they kind of were looking around to see if there was anything living. This is 350 degrees Fahrenheit in the middle, and that what they gradually found was that in areas not at 350, but maybe in the 200s, that there was microbial life that existed in very deep down in conditions that were previously assumed to be utterly inhospitable to life. Similarly, in glaciers, Antarctica, whatever, you'd think, oh, it's just a bunch of ice, I mean, nothing in there. Well, it turns out that ice in Antarctica, and probably in the Arctic too, is teeming with life, with microbial life. It is, as ice crystals form, the H2O becomes, it becomes the crystal, kicks out everything that isn't H2O, and there's kind of like a little rivulet, as it was described to me, that goes around. So any salts or any microbial life would be pushed out there. The salts make the liquid more habitable because it changes that temperature thing, and that's where the microbes live. And I went down to LSU, where these people were an LSU team. They go down to Antarctica. They bring back like 25 tons of ice. They melt parts of it and they look at it, and every block has microbial life in it. Underneath the ice cap of Antarctica, which is where 90% of the fresh water on Earth is an existing system of rivers and lakes that is very active. And in particular, this comes into play because you may have seen some things written last year about Lake Vostok. God knows I wrote a lot of them, and perhaps others did too. You may have seen others. Lake Vostok is one of the, well, to backtrack, when the U.S. Went to the magnetic South Pole in 1954, I think, and set up a station, we just kind of claimed it. The Soviets said, hey, we want to do something like that too. They couldn't go to the magnetic South Pole, so they went slightly off to what turned out to be Vostok Station. They didn't know it at the time, but 2 miles beneath them is a lake the size of Ontario, of Lake Ontario. And it is kind of the crown jewel of astrobiology on Earth. It has been covered like this for millions of years. There is, in that underground system, there is some water that comes in and some water that goes out. But basically, it is something that hasn't seen the light of day or anything that has to do with the surface for millions of years. And the Russians started drilling before they knew there was a lake. The discovery was made in 1995. It became kind of controversial because they were drilling with antifreeze and drilling oil, diesel oil, that if it had gone into the most pristine site on Earth, you could imagine how that would go over. But the Russians did work a lot with the international community, and last was it February? They broke through. This is going down more than two miles. Literally, they left the next day. I mean, they have a capsule that goes all the way down, and they have some of the water quickly be turned ice from the lake in it, and now pretty soon they'll be going back to pick it up. But it's so cold there that if you're not out by the end of February, then you can't fly. And then you have to spend the winter in Vostok, and apparently it's not that much fun. So that's something that's going to be coming up fairly soon. We'll get some of the first samples, and if it turns out that there is microbial life in there, and they expect that there will be, because in the core all the way down there have been things that they've found, then it kind of, it's a whole new page then. I mean, it's like, all right, you can have life in water, under ice, that's 2 miles thick, and hasn't seen the light of day for millions of years, which is kind of like Europa. One of the moons of Jupiter, it is known to have more water on it than Earth, but it has this crust of ice, and so kind of as a hypothesis, and now if Lake Vostok does come through and has microbial life, the possibility that there is such a similar kind of life in the oceans under the ice in Europa, it's looking better. The Atacama Desert in Mars is one of the real primary sites for astrobiological work because it's the driest place on Earth. Sometimes it goes some areas go 10 years without any water, without any rain at all. And it's seen as a Mars analog by NASA and ESA and others. And yet, you go down a couple meters, and you're going to find, or even less than a couple meters, and you're going to find microbial life again, still alive, and sometimes even just on the bottom side of a rock that hasn't gotten water in 10 years. Utterly unexpected 15, 20 years ago. In the world of skeptics, this is a subject that we might want to talk about later. This was about 2 years ago. There was another major paper in Science and a big press conference by NASA saying that this was in Mono Lake, California. This is Felisa Wolf-Simon, who is a young woman who led the research. And what her conclusion was that there was in the lake, and she had processed this through, so she started out with something and then just purified. She found microbes that did not have phosphorus in their proteins, in their DNA, in their membrane. And again, I didn't know that that was necessarily a big deal, but everything else on Earth that is alive has phosphorus. So this would be considered a huge break in the structure of what you need to live. And it's the whole idea of a shadow biosphere. I mean, when you think about it, if life started once on Earth, why didn't it start like twice or 3 times or 100 times? And we're just not looking right at what else might be there. I mean, this is a good place to start life, right? I mean, in any case, this research got clobbered by critics, a lot of skepticism, and kind of it became a real watershed in terms of skepticism about peer review versus community review online. There was a lot of hard feeling. Again, Felisa is someone who I now have spent time with and know she's working with some really top-notch people. It's not like it's, you know, this is not UFO land. And she remains convinced that this is the case and that she is going to prove it. And her skeptics remain, you know, still feel that that she was way off and that NASA and science, you know, were kind of gullible. Unskeptical. Why am I talking so much about microbes? I mean, they're really small. But they are a big deal. And of the roughly 3.8, 3.9 billion years that there's been life on Earth, as far as we know, about 3 billion, all there was microbes. And today, again, just a thought that when I learned it, I said, this couldn't be true, but it is entirely true, that the mass of life that's below the surface of the Earth, and by that I mean also the surface of oceans, the mass of life that lives down there is greater than the mass of life that lives above. So, like all those little microbes, put them together, and they're bigger than all the trees. You know, there's more mass than all the trees and all the elephants and all the everything else. And of course, we are something like what, 5, 10%, or 4, 6%, you know, just bacteria and microbes ourselves. And everything evolved from that. You know, there was just microbes for 3 billion years, and then suddenly, you know, there were cats. This was one of my, he's one of my favorite people in this field, Tantalizing. He's at Princeton University. The world of astrobiology requires and has fortunately found many people who think outside of the box. He was very interested in doing research on microbes deep in the earth. He had worked with some oil companies and, you know, kind of tagged along as they drilled down, didn't get very far. And then he thought, you know, what is the deepest cut on Earth that you could go down into? And it turns out it's the mines in South Africa. Some of them go down 3-4 miles, and they're going to probably soon be going down 5 miles. And he applied to and others for funding. They didn't give him anything. I mean, they said, this is crazy. There's no way that you're going to find anything down there. And he just on his own dime, went to South Africa, spent some time putting together associates to help him get into the mines and then go down in the mines and then and to set up a whole system, because it's a very complicated thing. All right, and now this is the kind of the prize that he came up with. It's called Desulfidorus audax viator. That the audax viator comes from H.G. Wells' Journey into the Center of the Earth, or do I have that right? But in any case, this bacteria lives down there, has lived there, again, without any connection to the surface for somewhere between 20 and 40 million years, complete darkness, and it's found everywhere around there. I mean, not necessarily in large numbers. And here's the amazing thing: the way it makes its living, because there's nothing from the surface that it could eat, and there's no energy source. There's radioactive rock, thorium, and other things down there. It gets the energy from that radioactive decay and uses that to split molecules of hydrogen sulfide and stuff like that, and it lives off that. That is how some of the earliest forms of life made their living, just by breaking down rock and using the energy sources nearby. When he came out with this it was maybe 8 years ago, again, initially there was enormous skepticism, but now it is kind of hailed as one of the great discoveries of the extremophile world, and it is understood that it's telling us something really important. When I went down, Tullis wasn't there, but this other gentleman, Gaetan Borgani, was there. He's a nematodologist, little roundworms. His understanding, the same kind of hunch that the many people from different disciplines into astrobiology, that feed into astrobiology had, said, what do roundworms eat? They eat bacteria. So if you're going to find bacteria, then you're going to maybe find roundworms that would go down and get them. So he was doing the same kind of sampling. We were in the end of a mine tunnel that was leaking water. It was really hot. I mean, it was like 140 degrees or something like that. And it was just so cool. It looked like a shipwreck. This was calcium carbonate, and it looked like it had been there for like 100 years. It had actually been there for 3 or 4 years. And you could just see in those kind of conditions how things work. In any case, Gaetan did a lot of work about this and came up with, this was in Nature, Worms from Hell. So 2.5 miles down, not only do you have bacteria, but you have what in comparison is like a really sophisticated thing. It has, it has a digestive system, it has a reproductive system, it does all kinds of things, and it is also living at that kind of depth. So what is this, what's the importance of all this? Boom, Mars. Today, it's really cold and dry. We'll talk a little bit about water, but as far as we know, there probably isn't much running water, if any, on the surface. The temperatures that Curiosity has to deal with, I think it goes down to about 100 degrees centigrade and up to maybe 25 degrees centigrade in one day's cycle, but it's mostly just extremely cold. And the theory is now, life, who knows if it's there, but back in the day when life was beginning here, it actually, before that, Mars was more habitable than Earth was. We were, you may recall, hit by a very large body that became the moon, and the Earth was just a mess. And there was also, this was the period of heavy bombardment of other asteroids, but at the same time, Mars was believed to be wetter and warmer than it is now. It was believed to have, or understood now, to have an atmosphere. It has a very thin atmosphere now. It had a much thicker one. And it had a magnetosphere, which is what keeps the atmosphere in. That has been destroyed. No one knows exactly how any of that happened. Curiosity, one of its missions is to do that. So in that time period, 4.1 to 3.7 billion years ago, it may be that there was life on Mars. And there's a whole school of thought that says, well, you know, life begins on Earth in a fairly short period of time between when conditions wouldn't allow it and then suddenly it's there. You know, is it possible that an asteroid hits Mars, kicks stuff up that has microbial life in it? You know, it sails around the solar system for a while, lands here, and poof, we're all Martians. It's possible. It's called panspermia as a theory, and it's given more credence than you might imagine. But in any case, the logic says, okay, if there was life on Mars back then, and let's assume that it didn't come here, but it was a separate kind of thing, and then conditions got really bad, the atmosphere disappears, maybe whatever was there just went down. You know, it went down into the ice and it went down into the rock as we now know it can. And it's going to take us a long time to find that kind of microbial life if it is there on Mars, but it would, I mean, what an amazing thing that would be. As Tullis was saying earlier, you know, in order for there to be life, you kind of need to have water. And you know, this is an relatively old image, gullies on Mars. This is the Watson crater in the Martian winter. That's the summer. Doesn't it look like a stream? You know, like something's melting and going down. You know, we just have the images. We don't know exactly what's going on there, but it might be a saline, briny kind of water. This from another perspective. And then comes curiosity, and this will return to water soon. Curiosity is far and away the most sophisticated, most expensive, and coolest rover or vehicle that's ever gone to another planet. It has 10 major instruments, the only ones that have, and instruments before had like 2 or 3. It has a chemistry lab, it has a mineralogy lab, it has a laser zapper, it's got all kinds of cameras. It's utterly amazing in terms of what it can do. It landed in Gale Crater, as those of you who are listening in August. Gale Crater is about 90 miles in diameter, and in the middle of it is this Mount Sharp, which is about 3 miles high. And that's the reason that they wanted to land there was in that at the bottom of that 3 miles high is they can see from orbit that there are minerals and there are clays, and those are the kinds of things that you look for in terms of the potential beginnings of life, and then also a record of life. Now this I will go through quickly because you folks may have seen this, but this is an animation of the thing of Curiosity coming in. It's coming in at 13,000 miles an hour. It has to go to 0 in 7 minutes. It had guided entry, which means that it was all out of the control of people in JPL. This was the biggest parachute supersonic parachute that's ever been used. They then had to kind of station it and then send it off again because what it had before wasn't enough. There were something like 75 different pyrotechnic rockets that were used to either loosen things or stop things or whatever, hover. This was the famous sky crane. That is just, I think it was 60 feet above the ground or 60 meters. And then, boom, it lands. And, you know, it worked. And then the thing cuts off and doesn't smash on itself. Adam Stelzer, engineering superstar now. He really does have Elvis hair and wears earrings and used to play in a rock band. This was mostly his idea. It's kind of like the new NASA, you know, with the Mohawk guy also. It's like, whoa, you know, these are engineers. And they landed. This is their first movement around. They're going to be there for 2 years, 2 Earth years, 1 Mars year. And everything is going phenomenally well. This is, I love this picture. This was the camera's arm. I mean, the arm can go way underneath, and so it's taking a picture. And you can see in the background, there's the bottom of Mount Sharp. It's like this is Mars, you know, and you could, they could take pictures of Mars. This is a little bit of false color, but you could, and the geologists on the team begin to took us out into the Death Valley area to teach us a little bit about geology. There's a major geological break there, and then you also have all these clays and silicates there. It's going to take a while to get to the bottom of Mount Sharp, but when they do, it'll be really mind-boggling. Back to water. This was their first big discovery. This is on Earth. This is what happens in a stream that dries up. You can see all the little round pebbles. It's called, and then it's in a composite kind of structure. This is right near where they landed on Mars. And they found the same composite, and they found the same kinds of little pebbles. And they said, you know what? There was running water here. It wasn't just like, you know, just like dribbles of water. It was running water, and it was running fast. They could tell by the size of the pebbles, and they say that it was doing thousands or millions of years. And this is the terrain. That's up in the corner there is the crater wall. So that's a high place that comes down. There's this alluvial fan, you know, which is what happens in streams and rivers here. That little the cross is where it actually was, where Curiosity landed, which is unbelievable because that's exactly where they wanted it to land. This is an area called that they've called Glen Elg, that they're on their way to now, which has 3 different geological zones coming together. That also has the thing in purple. It's an area of high thermal emission, which means that it seems to be more kind of concretized than regular rock. So it holds the heat a lot more than just what's on the side. I'm not entirely supposed to say this, but you know, in my reporting and research, these are the kinds of questions that come up. Got an alluvial fan, you got a river coming down, you got this kind of cemented area here, probably a lake at one time. Or certainly could have been, and you know, what kind of better environment for the beginning or for support of life than a lake? You're just sitting water. And then also the question that comes up is, this is fairly close to the Martian equator. We know that there's a lot of ice on the 2 poles. And the assumption has always been whatever water you saw, you know, we could see in caverns and whatever else that had once run, that water came from the poles. But here, you have water at a high point up there, you know, at the top of the crater rim, and it's flowing down there. And it raises the question, how'd the water get there? I mean, water goes to a low point. It doesn't go to a high point and then down. And some people are speculating that there was once rain or snow. It's all incredibly cool stuff. I mean, you know, this is just in the world of, you know, theory now, and people kind of throwing stuff against the wall. I know I'm running a little bit long already, but this is so much fun that I'm going to continue. Again, in the world of skeptics, Mike Muma is one of my heroes. He's the head of the astrobiology program at NASA Goddard. He grew up in Lancaster County, outside of Philadelphia, which is an Amish area, very fundamentalist in its religious beliefs. He grew up in a very fundamentalist family. He was, you know, a kid who loved to go outdoors, he used to tell me, and kind of just explore the woods and see, you know, we wanted to see what was there and to figure out how things really worked. And he didn't have a science class there until he was 11 years old. And in the science class, the teacher was talking about evolution and you know, all these other forces that were very different than what he had been taught by his pastor. For all these years, he would go to church 4 or 5 times a week. And so he went to the pastor when he was 11 years old, and he said, how do I make sense of this? You say one thing, and the scientists say the other, or the teacher. And he said, the pastor said, the teacher is wrong. Mike Moom at age 11 left the church. The first person, the first person in his family, in his broad family, to leave Lancaster County in more than 300 years. And he became this, again, real think outside the box kind of scientist. And his primary search has been for methane on Mars. Methane being what is produced by cows, in bogs, by us. It's a gas that is on Earth, about 90% of it is produced biologically. And he set as his goal to try to determine whether or not there was methane being produced on Mars. They had always found little traces of it, but it was not enough to be of use. I had the good fortune of going down with him to lovely Paranal, which is in the Atacama Desert. It's as you can imagine, when you have a big telescope, you don't want to have much light, right? And there's no light there, because there's nothing. We went for maybe 3 hours just driving through and saw, if you saw a boulder that big, you'd kind of think, oh my God, it's a boulder, because mostly it was just nothing. We came to this area and and stopped and pulled out by one of those white buildings, and there wasn't a soul to be seen. It was like a neutron bomb had gone off, and it's creepy. And then I was walked down to where that dome is, and the dome kind of looked like, where you put salt on the side of a highway. It had that kind of feeling. I was thinking, why are they taking me to this? We walked down, went through a couple of doors, and then, boom. This is what they had created under the Atacama. And this is where they live, and they eat, and as you can see, they swim, and God knows what else they do. It's really cool. In the nighttime, they cover it with really heavy plastic. And I show this one because it's just so cool, but also, when you think about it, this is how eventually, humans are going to be living on Mars or wherever else, if that's possible. They're going to be underground, and they're going to be doing this. Kind of like Tatooine, So I went up with him to the nearby telescopes. You spend the night there, and you're looking at stuff. It's beyond beautiful. It's just kind of, your heart just soars looking at all this. And this is the southern hemisphere, so there's the Magellanic Cloud and the Southern Cross and all this stuff. And soon after he put up this, he had this, again, a NASA science paper saying that there were these large emissions of methane at specific times at specific places on Mars. This has become, like everything in this field, or like much in the field, somewhat controversial. Some people disagree with it. You might have seen something in the last couple of weeks that Curiosity has so far not detected methane. Unclear that it could, given its capacity and where it is, and given the way that he describes the methane comes out. But if there is methane that is coming up from deep below and then erupting, there's this whole family of microbes called methanogens, and they live on, they make their living on rock and whatever, and they create methane. And then maybe when the ice melts, the methane comes out. All right, I had said earlier, this is some of the part who knew? Out there, all the makings of life, all the molecules, all the compounds, it's all out there. And there was a period of time when just the early bombardment period, where a lot of stuff was coming in, and it still is. 30,000 tons of cosmic dust falls to Earth each year, and it has a lot of these kind of compounds. Exoplanets. I said before that there were billions of them. It really did change everything. This is fascinating to me. Before the first one was identified in the mid-90s, it was speculated for years and years, going back to Giordano Bruno and others, that there were a lot of planets out there. But we didn't have the technology or the know-how to find them. And I see that as kind of potentially analogous or a parallel to what we're thinking about life. We kind of pretty sure it's out there, but we don't have the technology and knowledge yet to find it. More planets than stars in our Milky Way, and in our Milky Way there's something like 300 billion stars. So we're talking about more than 300 billion planets in the Milky Way alone, and then there are like hundreds of billions of galaxies. Insane numbers. The Kepler spacecraft, this is one of NASA's crown jewels. It's been orbiting for a couple of years now, and it looks at a small piece of the sky way, way out, and it is looking for planets that are transiting in front of their stars. It's a very highly precise and technical thing. It's one of two ways that they could find exoplanets. About 1,000 or 1,200 have been identified using a different method. These folks in a short time have several thousand that they have they've yet to be confirmed, but because they're so far away, but they are positive that there are more than 2,000. And initially they found large ones, but now they're finding more and more small ones as the technology gets better. The big ones are gas giants, and clearly are not going to have life, just like Jupiter or Saturn would. But smaller ones are what is the norm. And as we can see, ones in the habitable zone. It's interesting if you have, this is our sun. But if you have a different kind of sun that isn't nearly as powerful, then you can be much closer and still be in that zone where you could potentially have liquid water and not get burned up. So that's a rough estimate of how many stars there are out there. When I started working on this a couple years ago, there was a 2 at the beginning of that. So it's growing, exponentially. Just a brief aside, this woman, Sarah Seeger, she's a theoretical physicist at MIT. She was the youngest person to ever get an endowed chair at MIT. She was the one who kind of turned me on to this. I was at a journalist boot camp at MIT and on the universe, and 1 week you learn everything about the universe. And she came in, and of all the people, she's the one who really spoke to me and said, in my lifetime, we're going to find life beyond Earth. And MIT, brilliant woman. I'm thinking, not so much as a scientist, but as a journalist, what a story, and that's how I got started. She specializes in analyzing the atmospheres of exoplanets. This isn't a real picture, this is a rendering. And increasingly they're able to identify what compounds are in the atmospheres, and if they find oxygen or ozone in an exoplanet, then that will be pretty much a slam dunk that there has to be life, because oxygen and ozone bond very quickly with other compounds, and unless they were constantly reproduced or refurnished, then they wouldn't be there in large numbers in the atmosphere. So that's what she says. If you find a planet that is surrounded by a lot of oxygen, then you could probably get up to about 96, 97% confident that you're going to find that biology is producing it. All right, again, we're running a little bit late, but we're getting toward the end because what kind of life is out there? Now, clearly, microbes are really cool. We now know that they do turn into cats and us and everything else, but it's kind of the intelligent life that is also a significant part of the story and what kind of moves people on. But these are called snotties. they're an early form of microbial colony. Some people say, well, maybe it's snotties that are, that'll be the breakthrough. This is a nematode, as we saw before, Gaetan finding them deep, deep down. But in terms of intelligent life, here's where things get really complicated. The closest star system to us is Alpha Centauri, 4.2 light years away. Doesn't sound like a whole lot, but it's really, unless you can go into warp speed, you're not going to get there. Just recently, by the way, there was the first discovery of exoplanets at Alpha Centauri. So, if you want to spend your next 3 or 4 generations on a spacecraft going to Alpha Centauri, we might have a job for you there. I'm not sure what you'd find, but in any case, so if there is intelligent life, it's like really, really far away. Given the logic that I've described, there's really no reason to think that there isn't intelligent life, that the same evolutionary forces that played here, why wouldn't it play somewhere else? In the same way, why wouldn't this canvas that we have out there that can create life, why wouldn't that create life? So the world of SETI, search for extraterrestrial intelligence. This is kind of where, the skepticism level goes higher. They've been looking for radio signals that are out of the ordinary, that are not something that could be produced in nature for about 50 years. In fairness to them, they have still done just a teeny tiny fraction of what's out there. The way Jill Tarter, who's in the next picture, described it to me, the number of star systems that they've looked at is like taking a cup of water out of the ocean. But in any case, they haven't found anything, and it's really disappointing to them, and they really thought that maybe they would. This is in Hat Creek in Northern California. They were hoping to get 500 of these dishes. They now have, I think, 43. The money was given to them by Paul Allen of Microsoft, so there's credibility there. They also worked with the University of California, Berkeley for a chunk of time. That broke up recently because California has no money. But Jerry Brown just got, they just passed a tax increase, so maybe they'll get more. In any case, if you folks have seen the movie Contact, Jill Tarter was the fictional character there. She's actually a very serious and accomplished scientist, and she, I think, has left the SETI Institute as a director and is now trying to fundraise because they almost went broke last year. But they are a really serious operation. There's important science that's being done. They haven't come up with anything in terms of extraterrestrial intelligence. They may never. I learned about a SETI observation that was occurring in Japan, and for my book went over there. It was really interesting. It was done in a way that was in many ways similar, but in other ways different. This gentleman, Shinwa Narisawa, had organized 23 observatories in Japan. He has subsequently organized 18 observatories around the world to do a SETI observation of a particular star system. And he's a very ebullient, likable guy. At the end of this, he was up for 2 or 3 days, and he was pretty exhausted. There had been some press coverage in Japan about it, and he was getting a lot of phone calls. And he was kind of looking like more and more depressed. And I said, Shinwa, what's the problem? He says, whenever we do something like this, people call and they say, don't let them know we're here. You're letting them know we're here, and they're going to come and kill us. And he points out that they're actually just listening. They're not sending out signals or anything. But just FYI, it's not just Japanese citizens, but Stephen Hawking says the same thing. That the history of more advanced societies coming to less technologically advanced societies, which we would be at that case, generally doesn't work out for the less well-advanced society.
Just ask the Aztecs.
Yeah, exactly. And many others. Just an aside, There is now something also called Optical SETI, where they're looking for laser beams that would be sent out by intelligent societies. I mean, it's kind of hilarious that it's at Harvard, Mass, but it is in fact run by Harvard and Princeton together. And I add that because to say that this is not like wacky. These are serious people doing serious work. On the other hand, and I don't mean this in a disrespectful way. I had some conversations with this gentleman, Father Jose Fuentes, who is the head of the Vatican Observatory, has been for some time, and the observatory has been in operation for years and years. They have now a big observatory in Arizona, and he said, we welcome our ET brothers. They didn't want to do the Giordano Bruno thing again or the Galileo thing. They said, hey, we're on this. You got science. And I went to an astrobiology conference at the Vatican, and they brought in a lot of the best people in the world, and they had them there to talk about the same kind of science. Unlike any other science conference that I've been to, they didn't let me in. Some things changed. In any case. So in the world of astrobiology, of the microbes and all these other things, it's science, and it's like really cool science. Whoops, it's really cool science, and it is very cutting edge. And I think from a skeptic's perspective, you can say, the science needs to be rigorously looked at, but it is like really cutting edge science from some of the best minds in going on. In terms of the ET stuff, I mean the intelligence, they're trying to use science, but it's really still in the realm of belief. We have no reason to, at this point, say that there is or isn't, other than the kind of the speculative thing. But to leave you on a nice high note, this was 30 years ago or so, the spacecraft Voyager was sent out, and its goal was to leave the solar system. And this picture was taken very famously. Carl Sagan was still alive, so you can see it was a while ago. And he said, turn the thing around and see if you could take a picture of the pale blue dot of us. They thought that they were about to leave the solar system, so they said, okay, fine, we don't need our power anymore or whatever. Turned it around, took the picture. Carl Sagan died a long time ago, right? Still hasn't left the solar system.
That's the helium ball.
Right. So it's this is just kind of a vastness, and we are teeny tiny in it, and there is every reason to believe that there is the opportunity for life being elsewhere, and I just think that it's kind of a wonderful trip that the scientific community is on to try to find it. Thank you. Yeah.
That was nice that you ended with a Carl Sagan thing, because I think it was yesterday, was it? That would have been his birthday, and so some people were thinking about it. One of the things that you mentioned was if we have two different places with life on them, that suggests that there could be common throughout the cosmos. And yet you also touched on possibly the contradictory aspect of, well, maybe Mars and Earth actually had a shared origin. So I guess that's still open. We don't know that.
Correct. And there's this whole world of molecular structure called chirality that is kind of perhaps too complicated to get into right now, but everything, all sugars and all proteins on Earth are what are called right-handed in terms of the way that the molecule is structured. And there's no reason why that's the case. I mean, you go beyond, and everything biological, on Earth is right-handed. Things that are not biological are even. And trying to figure out whether or not something on Mars might be a different form of life. One of the ways that they think of doing it is looking at its chirality to see if has the same right-handedness. But yes, I mean that's something that they hope they get to that point where they can say, hey, did it come from, did we share? They're still obviously looking really hard. The Curiosity mission is not officially a life detection mission. It's officially looking for organics, the building blocks of life. In quiet moments, people at NASA tell me, well, we think we might, if we can find, if carbon 12, carbon 13 kind of, differences and whatever. But it is not a life detection mission. But it's a huge step forward if they can find organics there, which they did not find at the time of Viking. Then that would be huge. Yeah.
Well, kind of a damper on the folks that are doing the listening, because they're basically trying to see if they catch leakage of radio signals from other things, from other civilizations. But I was reading somewhere where, while we like to say that, well, our bubble of our radio signal is out like 40, 50 light years now, that actually the signal strength would be lost about a light year out against the background noise of the cosmos. And so that presents an additional problem, that someone's got to be broadcasting a pretty powerful signal for us to actually pick it up here. But I was seeing this just recently.
No, you're absolutely right. And there are a lot of things would have to be done in a very intentional, high-powered way by people who are very advanced in order to be able to do it.
Pointing a green laser up in the sky.
Yes, and not sending out I Love Lucy. But I went into the my SETI reporting thinking whatever. But I kind of came out realizing, one, that there is a scientific basis to what they're trying to do, and two, if you don't try to do something like that, what else you got? So it's a long shot, but it's.
Yeah. I assume they've done DNA sequencing on these very odd objects, living objects they found. Are they all related to the rest of us?
Well, they're related in the sense that they have a DNA structure, just like we do, and they have proteins and membranes and all that kind of stuff. So yes, either they came from that huge pool of microbes that was there and migrated down, or perhaps they were some of the origin of life. And another theory is Earth had some really bad days, snowball Earth and comets hitting and all this stuff, and conceivably the microbes that are really far down just survive a lot better, or did during those times. But yes, they would be coming from the same tree.
What do you think of Drake's equation? The equation that Drake had, you familiar with that?
Yeah. Are you folks familiar with Drake's equation? Just very quickly, it's Frank Drake was the one who kind of started SETI and has continued working on it. And he put together an equation with a lot of X's in it that would be a prediction of how likely it is that there would be intelligent, or actually not intelligent, but technologically evolved societies. And some of the X's are, the number of exoplanets, some of the very things that we discussed. And he put together an equation, and he came up with a likelihood that was pretty high, and over the years has gotten higher and higher. And it is, it may be bogus. I'm not bogus. I mean, it's sincere. And a lot of people put credence in it, but there's still so many X's that we don't know what they are. We can't constrain them one way or the other. But as time goes on, we're filling in more and more. We now have an exoplanet and X and galaxy X and stuff like that. So it's a tool that I think everyone thinks is not going to give you an answer, but is an interesting tool that might shed some light in the years ahead. Anyone else? All right. Well, thank you very much.